Hi everyone, welcome back. This is Raju from Smart AI Technologies. Today we will implement image processing for classification of rice varieties with deep convolution neural network, and also another IEEE paper called paddy seed variety classification using transfer learning based on deep learning. So these are two reference papers that we are going to take, and we are going to build our own deep learning model to get the results. Here they are getting 80% accuracy, 83%, or like that. They are using VGG 16 inception v3 and MobileNet v2, and in this paper they are getting 85% accuracies. And in our model, what we are getting and how much we are getting, here you can see the model we built. We are getting around 99.37% of training accuracy and 99.28% of validation accuracies. Here we are classifying all the rice. One is Basmati and the true level is Basmati, that is the true class is Basmati, and our model is predicting Basmati. In the same way I am predicting it for 10 images. There I am getting proper or 100% accurate result. As you can see how our model is giving accurate result. Here I am printing out the classification report. You can see what is the precision score, recall score, F1 score, and support for all the classes. Here almost it's 99% or 100% for all the classes. In the same way, what is the validation accuracy? 99.28% accurate, and loss is 0.02, that is 2% of loss is coming. We will be printing out the graphs as required, and then how we trained and how many epochs we trained. We actually trained for 10 epochs, and initially it was 98%, and in the end we got 99.28% for validation accuracy. Training accuracy was 99%. 99% is 99.37%. Before moving further, we'll see something. Okay. Here this is our channel, and we posted so many videos, and we are getting good response from all the viewers. Our some of videos got 10k views, 8k views, and 3k views within 1 month, within 2 months 3k views, like that. We are very happy to say that actually you are supporting a lot and watching a lot our videos. I think all the videos are very helpful for you. Yeah, thank you very much. And if you like this video also, you can subscribe and comment. You can visit to our YouTube channel, and you can watch some other videos which may help you to gain the knowledge. So we will continue with the coding part. Before moving further, we'll see what is our data set and what are the things it contains. Actually, the data set we are using contains 5 classes. One is Arborio, Basmati, and Ipsala, Jasmine, and Karacadag. Now we'll see how it contains, like what type of images it contains. Anyway, we'll be accessing all these things using Python, and we'll be displaying that. You can see these are the images. Yeah. Now I am using Kaggle. Because I am using this Kaggle dataset, there only I am making a notebook to run it. So we'll start with the code now. In the first part, I am importing all the libraries we required in the ongoing part. So now I am importing OS and glob. These libraries we use to access the files and the folders and sub files, like that. Content of the files using glob. Operating system is used to access the permission or access the files. Then comes NumPy. This NumPy is actually used to work with arrays. Then comes Seaborn, which is actually used to plot the graph. Matplotlib is also same. You can plot the graphs, you can display the images. Pandas is used to create any data frame or access any external data, maybe text file, CSV file, or Excel sheet. And what are the things below these? These all libraries are used during model building or the data preparation for the model. I'll be explaining all these things in depth and down. So continually watch it. Okay, I'll be explaining these things when we encounter them. So first we need to access the data. So what is the location of the data set? Okay, in my case this was the location. In your case it will be a folder like this. Okay, if the code which you gonna download will be something, okay, RESNET code, okay, transfer learning code, then you create a folder called dataset. Under that place all these subclasses, okay, all the 5 subclasses. Then you should give this name there, dataset, only dataset. Okay, instead of this path just give dataset. That will be your path. Okay, once you give that, we are going to access the directories, okay, that I am doing here. This part you can use instead of this. Okay, now I am going to access the access the classes, and there are 5 classes with us. We don't want this requirement.txt. We will not be using that. Okay, so then what I'm going to do is I'm going to take all the image complete path to a full path of an image. For example, this is my home directory. Okay, so that I will append what is the data set name. After that I will take the class name from above. Okay, and I will append that, and then I will get all the image names. Once I get all the complete list of all the images, we have around 14,000 images for each class. We have 5 classes, so this list will be that much lengthy. I will take that, and from each element in the list, what I will do is I will read the class name. Where is the class name? You can see after rise image dataset we will get class name here. I will extract this part of all the paths. It means it will show me what is the class that particular rice belongs to. So then I'll be getting 2 lists. One is the list of complete path of all the images. Next one is the class or the label. So using them I will going to create a data frame using with the help of pandas. You can see here I am going to concatenate both of them. Both the lists I am going to concatenate, and I will get another data frame. Now I will try to print how many number of images, how many number of data are there in each class. I'll be getting equal, almost more than 14,000. It means it's around 15,000 for each class, and that is well balanced. So our data set is well balanced. We no need to worry about balancing the data. So next, here I will go to split my data into train and test. So for test I am going to split it around 25%. For training it will be 75%. The remaining percent will be for training. And then to visualize how my data set is, so I'm going to use matplotlib to display some of the data. Randomly I will display the images from the data frame I created. So here you can see Ipsala, Jasmine, Karacadag. I'm bringing some of them. Okay, till now it was just importing the data set and visualization. Next we need to pre-process it. For that what we are using, okay, here I am using image data generator. What does this will do? And for that I am feeding input as a pre-process input. Okay, what are the function of all these things? We'll see it now. Pre-process input actually is an augmentation library. What does augmentation will do? Now image data generator will use pre-process input features. Pre-process input will contain what is the rotation, what is the shift, like that. It will contain so many parameters. I will show it here. You can see here, using image data generator we will convert our image data into some array data. will convert our image data into array data. So to convert that, what we need to consider, okay, whether we can convert that directly into arrays, where there are any options for us to make it better, to make it very meaningful and to increase the accuracy, what we can do before converting it to some arrays. So that process we call it the image augmentation. Okay, here we got these features we can do. Image augmentation, nothing but changing the parameter of the images and creating a new image from the whole data set and increasing the data set we already have to train it. So we can do width shift, height shift. Okay, for image augmentation we have one video in our YouTube channel, you can watch it, you will get it and you will understand it better, why we should do image augmentation and what is the importance of it. Yeah, then you can come back here and you can continue to watch it. Here there are so many options. You can change the rotation range, what is the width shift range, height shift range, and brightness range, zoom range and shear range, and you can augment the data and you can feed that to a deep learning model. Here I am taking that, okay, and I am this pre-processing input I am calling because there is some already pre-defined variables, hyperparameters. Okay, this pre-process input library contains those features, particularly fixed. For example, maybe it contains rotation range of 0 to 15 degree, width shift of this much. Okay, fixed range. Okay, there we can call them, okay, instead of experimenting it manually, they are best fit for our RESNET model, so I am using that. Then I need to here I'm making it as a function, train data gen. I need to use it. For that, what I am doing is I will call this train data gen. This will be having a function called flow from data frame. Here I will mention what are the data it should consider to convert that from images to arrays and apply all the augmentation and all the stuff whatever we discussed now. Now here what will happen? It will go to train. What is nothing but train? Here when we split the data, for train it took 70% and for test it took 30%. Okay, from the data frame above 70% of data is for train. So here it will take all the train labels, train images as an input, and for this validation I am taking test. For test generation I am taking test. You can here you will be having another choice. For validation you can take out half of this test also, or 25% of test you can take for validation, or while you split itself you can separately split for validation data set, that you can do. Finally, when I do that, 56,250 images came for training, 18,000 images for testing, and 18,750 images for validation. Then as I mentioned, here we are using pre-trained model for classifying the images. In our case, classification of rice varieties using RESNET 50. So I am going to first load that pre-trained model RESNET 50, and then I am going to make this fast. What is the importance of making this trainable fast? What is transfer learning? First of all, transfer learning, the model which is trained for some other huge data set, we are going to use its memory or its experience to train for our custom data. For example, if we have two people, one among them knows karate very well and another who know nothing. Now you want to teach both of them kung fu. Now it's very easy to teach a person who know karate a kung fu rather than a person who don't know anything about martial art. That is, he knew something. A person who know karate knew something about the martial art, so he will learn very fast the kung fu. In the same way, in our case, if I need to train it for rice classification, if I build a model from the starting or a base, it's very hard to get good accuracies. So instead of that, what if we can use some model which is trained well for some data, which it's very huge, we take that and we manipulate some part of it, and if we train for our data, we'll get better results. This is a idea behind the transfer learning. The same thing will happen here. So, but before that, we should remove the some unwanted parts, or we should replace the things according to our requirement. So RESNET 50 is actually trained for ImageNet. As you can see, wait, ImageNet, I think it's actually trained for ImageNet, which is having 1000 classes, like person, chair, table, like that. It is trained for 1000 classes for so many days on some good GPU. So we use that and we change. Okay, that is trained for 256 cross 3 images, but we need to mention our images is 100 cross 3. We don't want 256 size images, so we should mention it. Include top, we should say false. It means on top what will be there, the shape information will be there. Initially we should manipulate it according to our requirement. So trainable part also will say false, because we don't want the old information of the training thing, our maybe a basic things to be continued, so we make it false, so that we can define our own models. In the next, we will take that and we will define 3 dense layers. The end dense layer, you should mention what are the number of classes that you are working with. Don't forget it. Okay, if you forget it here, you will be getting loss, you will be getting errors. Then I am going to create a deep learning model and compile it. Okay, till now whatever we did, we created deep learning model. Now we should compile it. During compilation, you should mention what is the loss you want and what is the loss we need. Categorical cross entropy is one of the loss, and when it comes to cross entropy, we have another option called binary cross entropy. In binary, you should use that when you have two classes. If you have more than two classes, it's better to go with categorical cross entropy. And in the matrix, you can just define accuracy. Here I am defining early stopping function, that is my callback function. What does this will do, and why I am not using it, and why you should use it. I will tell you both of them. So early stopping, what I am mentioning is, I will say while I am training, here I am training for 10 epochs. While I am training, I will tell it after each epoch just check validation accuracy. If in 2 epochs, if you feel like validation accuracy is not increasing a lot, stop there itself, don't go further. Okay, this is a condition you can call it here. Okay, new line and comma callback equal to my callback, you can do like that. Okay, just the okay, callback equal to, you can give that callback function name. Here why I am not using it and why you should use it, that is the thing. Here I am not using it because I want to show you what will happen after 10 epochs. But in your case, why you should use this, you already seeing like, okay, what is the result coming, but you wanted to run it for 50 epochs. 10 is not enough, you want to run it for 50 epochs. But after 20 epoch, here I am running for only 10. After 20 epoch, 21, 22 epoch and next epochs, there is no improvement in accuracy at all. So in that case, 20 epoch is enough. Why you want to train and waste the time? Because it's taking a lot of time, and it will take a lot of time for you also to train. And why you want to waste that much of time where it's not improving any model property? So in that case, if you want to stop your model in middle, where from there there is no improvement in accuracy and loss, in that case you should use callback function. So then once the training is done, I am going to save that model, and once I save that model, I need to know what happened during training. So I will print out the history, I will plot the history. In that history, what it will have, it will have accuracies and losses. In the accuracy, what is the training accuracy and what is the validation accuracy. So when I saw training accuracy is rising properly, but when it comes to validation accuracy rose and it fall down. So there is no proper line here. What may be the problem? So we need to check it out. So to do that, you can train it till like 50 epoch or like that. Then you will understand. After 20 epoch or 10 epoch, it will stay properly. It means below, like from 2 to 8, it may be overfitting or underfitting problems will be there. So it's better to train for more epochs. You will get better results and clear results. The same thing will happen with the losses. Loss also is rising from 6 to 8 pop, and after that it's staying down. So for validation thing, and then I will test it using my test data. Then what will get, I will get 99% true rate accuracies with 0.02 loss. We can now create or generate classification report. Here I am using confusion matrix for that. What is confusion matrix and how to use confusion matrix to generate classification report? I will make separate video on it, but if you want to study it, you can study with some good articles. In this video I will not be explaining about that. So one thing you keep it in mind, almost precision is almost equal to accuracy. It may not fully equal to, but almost. Precision and accuracy are defined in the same way. So we can say, like, if the precision is 99%, we can say accuracy is 99%. Anyway, we will be displaying that thing here in the graph, or here also test accuracy. We will be defining or we will be printing those things. But during classification report, it will give us the feature like what is the accuracy or precision score for particular class. For Arborio, it's 99% precision, but you can see Ipsala is 100%. It means during testing, if you gave 50 images for testing, it predicted 50 Ipsala images properly. But when you give Arborio for the prediction, 1% it was giving error. It means if you feed 100 images for testing, one image is predicted wrong, and all other 99 images are predicted right. So in the end, I'll be taking some random images and I'm feeding that to model, and I'm getting predicted result that I am printing out with the original result, that is true result. So I'm just trying to show you how my model is working. I think in the path I forgot to explain about the libraries, so we'll go up here. Now you'll understand. Train underscore test underscore split is a library which is actually used to split the dataset, as you saw. So there we split it 25% for testing and 75% for training. Like that, you can split it in any way. So, and then from Keras, I'm using image data generator. As I shown you, image data generator is actually used to convert our image data into some array or tensor data. And then comes the model. Model is the library which is used to create or build the model. Now comes layers: convolution 2D, max tool 2D, flat, and dense, and the dropout. All these layers which you actually use to build a deep learning model if you start to build it from the base. But in our case, we are using only dense layers, because we are doing transfer learning and we only need the ending layers, that is the dense layer. So we are using only dense part. And then comes early stopping. I think I explained you callback and early stopping thing. RESNET 50. Okay, this is a model. This is a pre-trained model that we are using, and we are doing transfer learning on it. You can do transfer learning on any other models. If you want further help, you can contact us. We will be helping you completely with these things. Okay, because there are so many other transfer learning techniques. Not only the RESNET 50, MobileNet, Inception v3, GoogleNet, that's GoogleNet, and some other good models as the EfficientNet. If you want to use, or if you want to play with that, and if you get some error, you try yourself, and if you get some error, you can contact us. We will be helping you with that. Okay, so this was all about today, and yeah, if you want any further help, you can just contact us. If you like this video, you can subscribe and click on like button, and try to click on the bell button, because we'll be posting some other videos which may help you to boost your knowledge. Thank you for your patience and time. Thank you very much. We will see you in next video.